Hello, my name is Sarp Çavuşlar and I am working as a technical support engineer at ProtaSoftware. Today, our webinar topic is how to design math foundation with ProtaStructure 2022 version. Here is our agenda for today. I will quickly talk about the journey of Prota, what we offer, and the core advantages of our software technologies. After that, I am going to pass to math foundation design part of our webinar. Here on this map, you can see our offices, partners around the world. Today, we operate with more than 14 offices located in Poland, Peru, Turkey, Malaysia, Singapore and Philippines. Opening up another Europe office is among our 2023 annual plan, which will be located in Berlin, Germany, to increase our services across Western Europe. Besides our regional offices, we support our clients and provide services through our channel partners. We have 17 partners across Europe, Africa, Middle East, South America and Southeast Asia. As a structural engineers, we wear multiple hats. We do BIM modeling, analysis, create detailing, and we even create fabrication and constructible information. We also coordinate and share project information with other stakeholders and software through BIM. Our core advantages is that ProtaStructure suite offers these necessary features in a single suite. A software for streamlined modeling and analysis. A software for designing your steel connections, concrete beams, core walls, foundations, and more. A CAD software for dedicated structural drafting and producing all your engineering drawings, with components designed for other project elements like retaining walls. A BIM software for communicating all of these to other project team members. Here you see our latest technology solutions offered in a single suite for the structural engineering market. ProtaStructure for modeling, analysis, and design of your structures. ProtaDetails for your automated detail drawings. It includes intelligent rebars and design libraries such as retaining wall, scaffold design, and detailing. ProtaSteel for your steel detailing and automated connection design of your structures. There is a drawing and calculation reports within this technology. ProtaBeam to bidirectionally link your models with other BIM platforms and software solutions like Autodesk Revit, all planned on Archicad. Modeling, analysis, design, detailing, fabrication, and BIM in a single package. Here is our webinar content. Modeling approaches in the foundation systems in ProtaStructure, finite element model creation and analysis of foundations, math foundation design, punching checks, integrated finite element foundation reports, and the last one is the geotechnical preliminary design reports. So we can pause here, and if you have any questions, you can use the chat box. Now we can proceed with a live webinar of ProtaSoftware solutions. Now let's open ProtaStructure. I created a simple building, which building analysis was completed before. Now let's examine some of the settings regarding the slabs and the foundation. Since the raft foundation is defined by the slabs, you can want to examine these settings. You can change the parameters here under the slab settings. You can arrange steel bar selection, curtailment, slab steel pattern, bar spacing, and much more, such as appearance. In the foundation settings, you can arrange the values such as soil unit weight, soil vertical subgrade coefficient, foundation ultimate characteristic strength, foundation ultimate design strength, and much more. Also, if you want to design pile caps, you can change the pile cap settings from here. Let's close that window and pass to Materials tab. Okay, now let's examine the Materials tab. In the Materials tab, you can select the foundation floor section and you can change the concrete grade. You can change the soil material such as sand, clay, silt, or rock. Also, you can add a new soil material, and by to do this, you can arrange the mechanical properties or design parameters as well. Also, you can change the links, and if you want, you can select the rebar diameters that is used in your project. Now let's close this window and pass to modeling parts. In the mat foundation modeling, you will use slabs as I mentioned before. You can make a raft foundation model with a single slab, or you can define and apply separate slabs. If you want to use only one slab, you can pick axis methods for definition. However, in here, I will define 9 slabs between the axes. Let's define some slabs and change the thickness, and let's select the axis region insertion method and define slabs between these axes. And after that I will define cantilever slabs for the mat foundation. Let's define 85 centimeter length cantilevers around these slabs. Okay, it's completed now. Let's define slab strips. You should choose finite element slab strip, and if there are beams in your model, you should select the spot strip. However, if there are no beams in your foundation model, you should select fixed band strip. If you click the integral strip, your results will become more economical. Let's define slab strips over X direction. Also, you can arrange the scope width by using this tab. Also, you can arrange the scope width by writing length values, the left and the right parts. Okay, let's define it here. Okay, it's completed now. Now let's define slab strips over Y direction. I will define 4 slab strips like I did in the X direction. Okay, and one more. Let's arrange the width. Okay, it's completed now. Now I want to assign some area loads and the line loads to the sum of these slabs. Let's assign an area loads from the loading tab. Let's change the magnitude and define one of these slabs. Also, I want to assign line loads to these slabs as well. Now let's define slab openings to this slab. Change the B1 and B2 values. Okay, the slab opening inserted. Now let's pass to finance element foundation analysis. Before that, you should make the building analysis first. In the foundation analysis window, soil subgrade coefficient and foundation ultimate design strength are the two main parameters for foundation analysis. You can change the soil subgrade coefficient. You can choose the suitable values regarding to your model, such as clay soil, loose, sands, and much more. By the way, you can also change the soil subgrade coefficient of each slab. For this, you need to mark the user-defined parts in the properties section of the slab. Then you can change the subgrade coefficients. After changing the subgrade coefficient, you should use the subgrade reaction values assigned to slabs for the foundation base pressure parts. Also, you can arrange the materials that is used on your building from here. From the foundation floor section. If you click Include Column Sections in Finance Elements model, your results will become more economical. Consider beam torsion stiffness is used in the mat foundations with beams. Due to there is no beams on our foundation, we do not need to click it. You can choose to use leave reduction for all combinations in here. Also, you can choose to use sparse solver for finance element foundation analysis. In addition, you can arrange slab and rough shell element size. Okay, let's wait for the complete the finite element foundation analysis. The analytical model was created right now. Okay, the analytical model prepared. Let's examine finite element foundation analytical model. First, you are seeing the displacements. Also, you can see the displacements by animation. Let's open the plane view. You can look up the members from here. Also results. Okay, let's pass to contours. In the contours tab, you can select different load cases, combinations, and examine effects of the displacements, forces, bending moments, design moments, required steel areas, and much more. You can choose whatever load combinations you want, or you can choose to pick envelopes. Envelope means on envelope max. This is the standard contours. Also, you can look the colored lines and the line contours for visual interrogation. Also, these contours are created automatically. Now, let's pass to user-defined contours. Here, you can create contours manually. I want to create user-defined contour for direction 1 bottom steel. Click Edit User Definition and create a contour for direction 1 bottom steel. And first, I want to contour count to 5. Okay, let's select rebars. In the first contour, I select the diameter as a 8 and the spacing as a 25 millimeters. In the second contour, I select diameter as 8 and I add additional rebar, which diameter is 8 and the spacing is the same. In the last contour, I select the diameter as 8 and additional diameter as 10 with the same spacing. Let's click Update and wait for the creation of contours. Okay. The blue parts in the contours are sufficient when rebar is 8 and the spacing is 25 millimeters selected. The clay parts in the contours are sufficient when rebar is 8 and the additional rebar is 8 is selected. The green parts of the contours are sufficient when rebar is 8 and the additional rebar is 10. The orange part of the contours are insufficient when rebar is 8 and the additional rebar is 10. You can change your reinforcements as you wish by making adjustments from this section. Let's make similar contour arrangement to direction 2 bottom steel. Let's contour count to 5. And do some necessary reinforcements. This and click OK. Okay, the contours were created. Okay, let's pass to threshold contours. Let's click the threshold contours over here. Threshold contours are used to visually see if any effect in the list of the effects exceeds a certain threshold value. The maximum and minimum values are calculated and automatically written in the contour min and the contour max fields. Any desired value can be written in the lower threshold and high threshold fields. Values smaller than the value entered in the lower threshold fields will be shown by painting in red. The places between high threshold and the lower threshold will be shown in green, while the places exceeding the higher threshold value will be shown in red. Threshold contours can also be considered in a way a subset of user-defined contours, limited to only 2 contours. Also, you can examine the solid model of your matte foundation. Now, let's pass to design part. Let's close the finite element foundation model, analytical model, and pass to design part. I want to design all slabs from slab analysis and design tab, and I use slab strip design batch modes. Okay, it's completed now. Also, you can manually edit rebars, and you can take the reports from here. You can also change the report format to PDF and Microsoft Word formats. Let's conduct column punching check. If the punching check calculations are sufficient, it is written as adequate. If it is insufficient, it is written as insufficient. To get rid of this, you can increase the slab thickness. As you see, our foundation punching check report was created, and all of the columns are adequate for the punching check. Also, in the form plan, you can review the form plan from here, or you have it to drawn via ProtaDetails. Now let's pass to reports. First, you can take the base reaction report with text formats or CSV formats, Excel formats. In the finite element foundation report, it is a very detailed report. Firstly, you can add contours to this report. Also, you can find finite element informations, slab reinforcement calculations, punching checks, and much more in this report. It's creating now, and I'm waiting. Okay, it's created. In this report, you can examine soil parameters, base pressures, moments, mud foundation properties. Finite element nodes information. Also, you can examine contours, detailed contours in this report as well. All contours were drawn to this report. Also, this report has a slab strip profiles and punching shear checks. By the way, you can look the slab strips in the analytical model with different load combinations. Let's open the analytical model and examine the slab strips in the analytical model. Let's select X1 strip, and as you see, you can choose load combinations or load cases. And there is one more important report here, which is geotechnical reports. Preliminary summary for the geotechnical report. This report, which is preliminary summary for the geotechnical report, is very useful for civil engineers, especially the geotechnical engineers. In this report, you can see and review the project information, earthquake parameters, soil properties, analysis results, and the soil pressure values for raft foundation. From visual interrogation parts, you can see finite element contours on your model. Let's select finite element contours. Let's select one of the custom contour. Okay. Also, punching lines are created over here. You can also save and review these contours as DXF files from Beam Ribbon tab. Okay, let's close it. Our contours and punching lines. And thank you for attending the webinar today. I hope that it was very useful for you. This webinar record will be uploaded to our YouTube channel. Hope to see you in the next webinars.